This Typo cost NASA $200 million. We are at the Cape Canaveral, Launch Complex 12, July 22, 1962. Behind me is the Atlas Agena. It's a 30-meter ballistic missile converted into a delivery vehicle. The package? Mariner 1. A 200 kilograms of instrumentation, 7 main sensors held together by magnesium alloy and gold plating. It can completely determine if the environment is habitable by a human. Our target is Venus, 40 million kilometers away. At this distance, the delay in communication is massive. Everything, sensors, navigation, relies on the guidance system. This isn't just a rocket, it's a flying computer that should accomplish first ever planetary flyby in human history. Right now we are at the mission control room, seconds before launch. Let's see.
3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it is...
The rocket is away. We are monitoring the primary radio link. This is our only link that sends steering commands from our ground computer directly to Atlas engines. We've lost primary control link. Ground signal is dead. That's expected. From now on, the onboard navigation will take control. The backup software is live. Wait. The rocket is pitching. It's going off course. The onboard navigation system will take care of it. It's the exact same logic we used in the last successful Atlas flights. It's not fixing, it's overcorrecting. The yaw is at 6 degrees and climbing. The rocket is aiming at the populated area. How much time before separation? Only seconds left before the secondary boosters separate from the primary rocket. After that, it's impossible to destroy the rocket safely. How do we proceed? Let's wait and see. We can't just destroy it. Years of work up there, not to mention millions of dollars. We have to call it. It's heading for the coast. If we don't act now, we are looking at a catastrophe. Okay, RSO, your call, over.
Roger, initializing self-destruct sequence.
1 minute 15 seconds, velocity 2,900 feet per second, altitude 9 nautical miles, downrange distance 7 nautical miles.
293 seconds. That's exactly how long the mission lasted. The wreckage is at the bottom of the Atlantic. Now we have to figure out what failed. The hardware didn't fail, the engines were firing. The sensors were working correctly. In fact, they were working perfectly. The readings are correct, and that's what made the onboard computer panic. During the flight, every rocket experiences noise, minor vibrations, like fuel sloshing in a tank or wind shear. The primary ground link usually filters this out, but when we lost that link, the onboard computer took over and everything went sideways. The guidance equations were written in Fortran, formula translation, a scientific programming language developed by IBM just 5 years before Mariner 1. But it's 1962. Talking to a computer is not as simple as typing on a keyboard. We write the code on the paper, and the transcriber transcribes them to punch cards. The only way to talk to the computer. And let's see if the problem is here. In the original handwritten manuscript, the engineers included a specific symbol, a bar over a variable r. In mathematics, that bar signifies a smoothing function. It tells the computer to calculate the average of the data points over time. It says, ignore the noise, look at the trend. But when the transcriber moved the formula from the paper to the computer, they missed the bar. They treated the overline as a hyphen, or ignored it entirely. Without that smoothing function, the computer saw every tiny vibration as a massive change in direction. The rocket shifted a fraction of an inch due to vibration. The computer thought it was way off course. It jerked the engine to compensate. The jerk caused more vibration. A feedback loop of pure logic began until it became unfixable. The software was not broken. It was doing exactly what the code told it to do. It was searching for a smooth path using raw noise. But this is the exact same program used in the previous successful launches. So what made it fail now? The error didn't show up in the previous launches because we never lost the radio link before, meaning the program was never ever run. As we call it, the most expensive hyphen in history was just a dormant bug in our code. A bug that was always there but never surfaced because the program was never ever run. The cost was $18.5 million in 1962 currency, or adjusted to today's currency, $200 million. But it made us realize that quality assurance is also needed for software. It was basically the birthplace of software testing, and we realized that software isn't just math. It's a component that can explode just as violently as a fuel tank. We spent next 36 days auditing every single line of code for Mariner 2. We checked every punch card against the original ink on the paper to rule out any bugs. August 27, 1962, we are back on the pad with Mariner 2. The hardware is identical, the sensors are the same, the only difference is a single line of ink on a piece of paper that finally made it into the machine. The moment of truth. Will the launch be a success?
3, 2, 1, and liftoff.
We've lost primary control link. Now let's see if the program behaves. Onboard guidance is taking over.
And liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
And we've got a successful launch. Mariner 2 didn't nosedive. It keeps going. December 14, Mariner 2 has reached Venus. We just got the first ever data from another planet. Surface temperature 475 Celsius degrees, or 900 degrees Fahrenheit. Rocky, volcanic landscapes and deformed mountains under thick clouds of sulfuric acid. No water, no life. We found our answers, but we learned a harder lesson back at the Cape. The software is just as important as hardware, and if left untested, it will backfire. For more digital disaster documentaries, consider subscribing. See you later.